This is the biology end of course test / Georgia milestone data overview for Kell High School. My name is Angie Bagley, and I will be giving you a general overview of the school and a kind of in-depth examination of our biology state standardized testing data over the last few years. Okay, before we dive in too deep, I want to go over a couple of key points that I'm hoping to articulate throughout this presentation. The purpose of this overview is to examine how student populations have changed, both in terms of enrollment numbers and student demographics over the last 5 years, and to compare student test performance on the biology and of course test or Georgia milestone over the last several years, as well as examining this most recent year's milestone scores for biology specifically, to look at where potential achievement gaps may lie, and to also try to isolate strands where student proficiency is perhaps a little lacking, those areas that we can most readily address, or should most readily address in order to improve overall performance. So it's not only looking at the school and how it's changed, but it's also looking at through the lens of the biology state standardized test, what's going well, what's not going well, what's really in need of attention. This slide, we're going to examine some enrollment data, both in terms of numbers and in terms of how the student population at Kell has changed between 2012 and 2016. If you look at the line graph, you can clearly see that our enrollment is steadily decreasing. We are currently the smallest school among Cobb County high schools, and those numbers are not expected to reverse themselves anytime soon. Though that in and of itself is kind of interesting because of the geographic and redistricting changes in my area of the county, what is also interesting is how our student populations, when broken down by ethnicity, how those demographics have changed over time. Over the last 5 years, our majority population has been white students, with Black or African American students as the second largest group, followed by Hispanic students, then Asian and multiracial, and then a tiny smattering of American Indian or Alaskan Native. However, again, if you look at the second graph, you can see that the number or percentage of white students is decreasing from year to year, while the percentage of Black and Hispanic students are both increasing from year to year. Asian and multiracial students are staying fairly consistent. They're small populations, and American Indian or Alaskan Native is incredibly rare at my school. It's only used by a handful of students. I feel like this is interesting, particularly in my line of work, because as the ESOL coordinator, I wind up working with especially the Hispanic and some of the Asian populations in my school. A lot of those kids, those numbers growing, means that my students, the number of kids that I work with through the ESOL program, grows as well. So in a lot of ways, that's really exciting. But as you will see later, there are some troubling aspects in terms of how well we are serving these student populations as they grow and as they presumably, from the data here will continue to grow in the future. Okay, here we have a general breakdown of student services at Kell High School for the 2015-16 school year. Just over a third of our students are classified as economically disadvantaged, 36.2%, which is not nearly as high as some parts of the county, but is still a fairly high number. 2.5% of our students are classified as ELL, or English Language Learner, and those are both our active and our monitored Year 1 and Year 2 students. Even though the monitored students are not directly served in an ESL classroom, they're still factored into those numbers until they officially exit the program after 2 years of monitoring. 15.6% of our students are classified as gifted. 14.5% are classified as students with disabilities, and just under 18% are classified as remedial, which at our school means that they are recipients of any number of different kinds of services. It could be that they are repeating a class. It could be that they are enrolled in math support in conjunction with their math class without being also served through special education. It's a tricky creature, and the criteria for classification is a little vague, but all in all, it tends to help identify students who need extra attention and extra remediation. So it seems to be doing its job. As you can tell from this information and the student population breakdown on the previous slide, we've got a lot of variety going on at this school. We have a lot of overlap between some of these groups. A lot of our ELL population falls in with our Hispanic student population. A lot of our remedial population also falls in with Hispanic and with our African American students. Our African American students and Hispanic students also are a significant portion of our economically disadvantaged students as well. But all things taken into consideration, the wonderful thing about Kell is that it is a place of diversity and variety. It's never the same thing day to day, but the students are great. The population is, and I said it's very diverse, but it's really genuinely wonderful. It's part of why I have enjoyed working there so dearly over the last 4 years. Here we're going to start looking at some of the comparative data between Kell High School, the Cobb County High School averages, and the state of Georgia averages. And we'll start with the CCRPI scores. If you look at the trends, in general, with the exception of 2013, Kell High School outperforms the state average and underperforms compared to the county average. 2013 was a little atypical, as we outperformed the Cobb County average. If you look at the lines representing Kell and the state average, you can see that the pathways they take are fairly similar. Though Kell is consistently higher, the progression of CCRPI scores between the two groups are parallel. I think that's pretty interesting, and I think also indicative that somewhere along the way we're doing something right, because The patterns evident in our school's performance are also evident in the state as a whole, and yet we are still outperforming the state score-wise. For the purpose of this data overview, I chose to examine the biology end of course test / Georgia milestone scores over the last several years. And you may be wondering why, as an English / ESOL teacher, I'm choosing to look at science data. And I have what I think are some pretty solid reasons for it. One, with the shift from the end of course test to the Georgia milestone, in looking at the domains and the domain percentiles and how those have changed as the test changeover has occurred, biology has been one of the most consistent in terms of what is tested. It also benefits from not having the addition of a constructed or short response section, which the math and English language arts milestones now contain those elements. The math classes also have a pretty high number of repeaters, especially among algebra and geometry. Those courses assessed by the milestones. Our biology classes, on the other hand, tend to have pretty consistent pass rates, so the majority of the test takers that we're looking at are first-time test takers. I also chose biology because it contains what I consider to be less data distortion. Over the last 5 years, biology has been the core science class for either 9th or 10th grade at Kell. It has shifted back and forth some during those 2 years, but you're generally getting the same roughly group of students. Additionally, biology only has 3 varieties of class that take the milestone. You have your general ed on-level biology, you have co-taught biology, which would include students who are served in some capacity through special education in the biology classroom, and you have honors biology. No AP, which simplifies things, in my opinion. When you get into economics and U.S. history and American literature, there are on-level, co-taught, honors, AP, and between AP testing occurring at the same time as milestones, there's just a lot of different factors impacting that data, and it seemed to be a little too much for what I wanted to really get at here. So I went with biology because it seemed to be able to give us the clearest picture in terms of looking at a snapshot or series of snapshots of student performance among Kell students over the last several years. All right, let's start the in-depth data examination by looking at the 2015-16 school year results for Kell High School for the biology Georgia milestone. This first chart represents the percentage of student test takers who scored at the various proficiency levels. The orange color represents level 4, the highest level of proficiency. The red represents level 3. Level 2 is represented by the brown, and the green represents level 1, which is our really dire straits students. Now, if you look at this graph or this chart, really just at first glance, things look pretty good. 70% of our students that took this test in the 2015-16 school year scored at an overall proficiency level of either 3 or 4, and that's great. The concern is going to be more in the level 2 and level 1, that additional 30% of test takers, and trying to identify what students, not individual names. I mean, that data is readily available, but are there any trends? Are there some generalizations or some theories we can run with in terms of perhaps why those 30% are not testing at an adequate level of proficiency, which would be a 3 or better. So that's going to be what we look at in more detail in a couple of slides. Okay, so you've seen our overall student achievement proficiency for the biology milestone on the previous slide. This just provides a really quick little snapshot comparing the county proficiency level with, or the county milestone results for biology with Kell's results. And this chart manages to show the mean grade for both groups, the percentage passing, and the percentage proficient. Keeping in mind that with the high school milestones, a level 2 is not deemed proficient, but it is technically passing. So if you look at this chart graph, you can see that the orange represents Cobb County, the purple represents Kell, and big props to our biology teachers at Kell High School, because you can see that that purple is consistently higher, indicating that Kell is outscoring the county averages in terms of biology. And our biology department has really just run with all kinds of ways to improve the program this year. So this was kind of a cool chart to look at, because it really kind of contextualizes all of the work that my colleagues at the school have put in, and really sort of sees the fruit of their labors. All right, if we look at the data of the passing rates over the last 5 years on the biology end of course test / Georgia milestone for both Kell High School and Cobb County, you can see that there in 2015 was a dip in both groups, but you can see that Kell has consistently scored higher, and while in between 2015 and 2016, the Cobb scores actually dipped slightly. Kell's skyrocketed up from about 76% to almost 93%. This goes back to what I said earlier in the presentation about the incredibly just mind-blowing amounts of work that the biology teachers at Kell have put in to really identifying student learning complications or any points of confusion, and really remediating that learning and really addressing areas of weakness within instruction to really enhance student learning overall. I think it's interesting that there's some similarities in how the lines move, but it's kind of when the county has a fall, so does Kell tend to, but not only do we bounce back, but we bounce back more. So I'm kind of proud of this, even though nothing that I do is in any way directly responsible for these biology results. It makes me very proud of my school to see that comparison. Okay, before we get into the breakdowns of individual domain or strand performance, a couple of things that you need to take into consideration. The full domain scores for the winter 2015 administration of the milestone and the spring 2016 administration were only available in the domains of cells and genetics. Because we're on block schedule, we had students who tested at both times. When we examine other domains, the other three domains, we will only be looking at the winter 2015 test administration. So just please keep in mind that will be a smaller pool, and it'll be indicated how many students we're looking at, but just take that into consideration, that it is, as of yet, an incomplete representation of the data, but it is the most accurate, up-to-date information that I was able to get my hands on. All right, here we have a breakdown of strand or domain performance data for the 2015-16 biology milestone. Specifically, on this slide, we're going to be looking at the domain of cells. And something to keep in mind, while overall student performance levels were broken down into 4 tiers, at the domain level, it is just broken down into 3. So that is why you will not see any level 4 over the next several slides. It's because it maxes out at 3. So if we look at this, we can see that for the cells domain, of the 302 students tested, almost 80% of them, 78 to be precise, scored at level 2 or level 3. That is it's pretty good. I know that we want to see those numbers grow. We want to see that level 3 group expand, and we want to see a level 1 group diminish. But this is a pretty strong representation. Okay, on this slide we are looking at the second of the 2 domains that I was able to get full information for, or I was able to get proficiency scores for, or proficiency levels for all test takers, whether they were in the winter administration or the spring administration. And this is for genetics, and once again it was 302 students tested, and we see a fairly consistent performance to the last slide, in which nearly 80% of students test at either level 2 or level 3. And we've got, as opposed to 22% on the last slide, 21% that are still at that level 1. And we're going to be going more into those level 1s when we start looking at the some breakdowns in terms of achievement data, achievement gaps, and when we look at the various subgroups. So keep that sort of 20% number in mind. It's the needs of that 20% that we're really going to be trying to target as we go a little deeper. And while the last couple of slides have shown a lot of the good, now we're going to look at some of the not so heartwarming news and identify where some of our problem areas are. This slide titled "Achievement Gaps" is it's a breakdown of proficiency based on ethnicity, and because we have some very small groups that were tested, I have sort of clarified with a chart over to the side of how many students were in each ethnicity subgroup, just so that you can kind of take that into mind as you're looking at these charts. Because obviously, when you have a sampling group of 3 kids or 6 kids, the breakdown is not going to be, even under the best of circumstances, comparable to what you get with a group of 188, as in the case of the white students tested. As you can see, the majority of our level 4 performers come from our white students. Our Asian subgroup has the distinction of being composed of entirely all level 3 and level 4 performances, but those are only 6 kids, so it's a kind of an outlier. We see that the Hispanic group, which is only 8 students, but anecdotally, this is sort of substantiated by the data I started looking at in other content areas as well, that our Hispanic population has only level 2 and level 1 performances here. That even with that small of a sample group, to me, that's indicative of an area that at the very least warrants a more in-depth investigation. The African American Black students, also about half of them are showing as demonstrating proficiency at level 2 or level 1, which is definitely far short of where we want them to be. And they have a smaller than 10%, really closer to 5% performance of at level 4. So that's another thing that we want to work on. Percentage-wise, their level 3 performance or proficiency is fairly on par with that of the white students, and is fairly comparable to the school average overall. But what we want to do is try to increase that level 4 group and decrease those level 2s and level 1s significantly. Okay, so we've reached the end of the presentation, and what I want to leave you with are a couple of thoughts / questions to hopefully guide and inspire some conversations over the next couple of days, weeks, months, to really kind of help shape our instructional practices. A couple of things we're doing really well is that our biology pass rate is fantastic. It's not 100% though, so there's always room to increase it. And what do we need to do to try to bring that 7% up to passing? And how are we going to maintain with a whole different group of students that those pass rates stay consistent? Because if there's one thing that I have seen is that we are a little up and down in terms of performance. We're high right now. Let's keep it there. And by high, I mean high scoring. Nothing funny. I also want us to look at this, look at these areas of weakness in terms of domains and in terms of student subgroups, and identify some student learning problems. Where are the weaknesses? And not put blame on the students, but say, okay, why? Why is this group underperforming? Or why is this domain so challenging? It's not a write-off, it's not a statement, it's the beginning of a conversation that will, at the end of it all, if we do our part, result in a better standard of education for and better student performance for our kids, which is why we do what we do. When the full scores for all domains become available, would warrant some in-depth examination of the other 3 domains that were not examined today. And also, our biology teachers are doing a lot right. What they did between last year and this year was phenomenal. So, in addition to giving them the, looking at where they can improve, because again, there's always room for growth, I want them to reflect on what practices were truly effective for them and for their students. And I would like for them to also share those strategies with the rest of the faculty. Some may not translate well from one content to another, but a lot of them will. Best practices are best practices. So what they're doing to click with Kell students in the biology classroom is at least a great jumping off point for trying to find a way to help them be successful in other courses as well. So please consider all of these things. You all know where to find me. I'm down the hall in the room with the bright pink rug and the My Little Ponies on the bookshelf. Drop in, say hey, ask questions. Let's really get a conversation going about this. We've looked at this great example group, identified strengths. We've looked at some weaknesses. We see how they compare with the county and the state. So let's get into the nitty-gritty and start asking why, and then move forward, hopefully with some ideas to improve our overall instruction. Thank you.